Hi everyone, my name is Nana Indiana from Group 7 Senior Mechanical Lab class on Fall 2021 with my project Comparative Analysis of Fuel Consumption through Air Screw Settings on Suzuki Shogun 125 carburetor. This time, my project will be based on the concept of thermodynamics, where this science is a branch of physics that discusses the conversion of heat energy into other forms of energy. And this time, I will bring up the specific topic of what happens in the combustion of fuel in a two-wheeled vehicle. The purpose of the experiment is as follows. The first one is to determine the difference in fuel consumption by changing the turns of the air screw on the carburetor system. The second one is to be able to understand about the concept of how a carburetor system works. The third one is to be able to conduct an analysis about how the air screw on a carburetor could affect the fuel consumption on motorcycle. So for the first one, I think I'm going to explain about the carburetor and air screw. But the carburetor itself has the function to mix fuel with air in the right size as needed to then be channeled into the combustion chamber cylinder in the form of fog. Inside the carburetor, there are several kinds of components that have their respective functions. In this experiment, the component's behavior that were being observed is the air screw setting. The air screw has the function to adjust the air to be mixed with the fuel and is usually adjusted with a screwdriver. So basically, the carburetor works using the Bernoulli's principle. The faster the air moves, the lower the static pressure, but the higher dynamic the pressure will be. Now I'm going to talk about the variable measured and how I'm going to measure it. So the variable measured is the fuel consumption. The fuel consumption is the amount of fuel used per unit distance, for example, liters per 100 kilometers. And the formula is the fuel needed over the distance traveled. And how I'm going to measure it is the first one for the fuel needed, I'm going to calculate how much liters it takes to fill up the tank until it's full after going through some amount of distance by the vehicles. And for distance travel, I'm going to measure this one using the odometer on the motorcycle. And one thing that I want to explain here is about the fuel consumption and fuel economy are two phrases that are sometimes used interchangeably but have a very different meanings. The core difference involves fuel consumption, discuss how much fuel a car consumes to go a certain distance, and fuel economy measures how much distance a car gets out of fuel. So in this case, I'm going to measure the fuel consumption one. So the lower the value, the more economic a vehicle is because it means that the less fuel it needs to travel a certain distance. As I'm going to record several variables, there are also several expected error. The first one is for the fuel needed. The expected error is the fuel is not completely filled after traveling in miles of distance, so the recorded fuel numbers are not very accurate. Therefore, the fuel needs to be filled slowly to be completely full and in the same amount of how it was before used to travel. And the second one is the start and end record of the distance traveled in the odometer is only able to show up to 1.1 accuracy. Expected error in this experiment can occur due to several external factors that can affect fuel consumption regardless of the engine condition, some of which are as follows. The first one is a traffic jam situation where the position of the motorcycle idles but the engine is still working. This is also could affect the fuel consumption rather than just the carburetor system works. The second one is the road condition that are uphill, bumpy, and damaged can also could cause uh, high amount of fuel consumption. And the last one is the hotter the air temperature, the higher the evaporation of the fuel will be. And the next one is for the experiment scenario and the condition. For the road condition is dynamic, some for inclines, flat roads, smooth roads, and also the broken one. And for the speed is stable on 15 km per hours and 40 km per hours when it's traffic. For the weather, it's a bit sunny, cool, and windy. And for the passenger weight is around 130 kilograms for two-person. And for the driving style is safely aligned. And for the experiment time is around 7 a.m. until 9 a.m. And for the first scenario is the distance travel around 30 kilometers, 15 kilometer first route, 15 kilometer going back to the same road. And the air screw turns is normal, which is 3 turns. And for the second scenario is the same with the distance travel, but the difference is on the air screw turns is decreased into 1 turns only. Now is the important part, the experiment data and analysis. The experiment was conducted by going 15 km on the first trip and take another way back of 15 kilometers to the initial place with a total of 30 kilometers distance travel. The experiment was conducted with two different settings of air screw, the normal and the decreased number of turns needed. The data shows that the carburetor with the normal setting of air screw is consuming a light amount of fuel than the one with the decreased turns. Why is exactly this difference could occur? Indeed, in adjusting the composition of fuel which is more than air, the engine won't heat up easily. However, this will makes the fuel becomes wasteful and leaks. Vice versa, if the air composition setting on the carburetor is too large or too much, the engine will suddenly die or overheat and the engine pool is less responsive. Now the question is, how exactly an air screw affect the fuel consumptions? So the carburetor contains a mixture of fuel with air because its function is to mix air and fuel for an internal combustion engine. Therefore, the air screw plays an important role because it will determine the amount of air that will be mixed with the fuel for the engine to have a complete combustion. Under these conditions, the composition of the mixture between air and fuel must be in the right amount by adjusting the screw for the air. An air-fuel mixture screw is a special screw on engine's carburetor that controls how much air mixes with the fuel. And as adjusting the screw changes how fast or slow an engine idles and how smoothly it runs. The basic process for adjusting an air-fuel mixture screw is the same for all small engines, whether it's on a car, motorcycle, or other type of engine. Make adjustments. We first make adjustments with the engine warm up and running, and then we set the screw in the position where the engine idles most smoothly and doesn't sound rough or irregular to balance the fuel mixture so that the engine has an ideal fuel air-fuel ratio. Uh, that's a bit explanation about the air screw itself, and I also have attached here a picture of the position where the air screw on my motorcycle, which is the Suzuki Shogun 125. Now we have arrived at the last part of the presentation, the conclusion. So the settings the standard the factory motorcycle air screw is not too difficult unless it is injection. But for ordinary people, when setting the air screw, they usually just twist it around the adjustment bolt without knowing whether the setting is right for the motorcycle or not. Ideally, the composition of the air-fuel ratio should be just right, not wet and not too dry, so that the engine works optimally and produces maximum power with efficient amount of fuel. The bigger we set the twist for the air screw, the lower the fuel needed for the combustion process. And if we set the air screw too small, then the engine tends to spend more fuel to work optimally. I think that's all about my presentation and the conclusion of my project. Thank you and see you on another chance.